Okay, we're going to evaluate a limit in this video. This is a special limit because our variable is approaching infinity. So if you follow these steps, you should be able to evaluate any of these limits approaching infinity. It's really not that difficult after you see how it's done. So let's get started. Taking a look first at all the denominators, we're going to go one term at a time and look at the highest power of x. So we have x to the third power, second power, first power, and technically the 0 power sitting next to this 9. Next, what I'm going to do is go ahead and multiply both the numerator and the denominator by 1 over that highest power of x. All right, so multiplying by 1 over x cubed over 1 over x cubed. This is like multiplying by 1, so it doesn't actually change it. It only affects, it's just rewriting it in a nice strategic way. Next, you're going to go ahead and distribute that 1 over x cubed to each one of these terms in both the numerator and the denominator. I'll go ahead and speed this up and come back on the other side and explain exactly what our next steps are then. Okay, now that we've gone ahead and distributed that 1 over x cubed to each and every one of those terms, both numerator and denominator, next what we want to do is go ahead and do a little bit of simplifying down. So as you can see, we have an x cubed over an x cubed. That's going to simplify down and just make that 2. Now on others, it's not going to completely simplify down to just a number. But we got 2 for that first term. The next term is going to have 2 x's cancel out with 2 of these x's in the denominator. That'll leave us with 2 over x. Next one, we only get to cancel one of these with one of those, so we still have 2 remaining in the denominator. So 3 over x squared. And then finally, the plus 9 over x cubed comes along. Same thing's going to happen here in the denominator. Going to go kind of quickly as we go through this, that these 2 cancel out with this one. So we still have 8 over x in the denominator. Plus 1 cancels out here with one of these, still have 2 in the denominator. And finally, that 9 over x cubed remains in our denominator. Now that we've simplified, we can actually take the limit as x approaches infinity of each term, basically one at a time. So we're going to think about as x becomes a very, very big number, what's going to happen to each individual fraction? Well, it doesn't do anything for that 2 at the beginning. But if we go 2 over x, the next one, that's going to become a 0. Right? If the denominator becomes very, very big, then overall that becomes a very, very small number approaching 0. Same thing with 3 over x squared. That's going to become 0 as well. 9 over x cubed, well, the denominator is getting even bigger, even faster there. All right, so if we wanted to, we could go ahead and add those in here, plus 0, plus 0, plus 0. The 2, that constant, is going to remain a 2 in the denominator. But then each one of these fractions also becomes 0. If you want to kind of show your work, you're going to add a bunch of zeros in here. But adding a bunch of zeros doesn't really change anything. Or even if those were subtractions in between instead of all additions, it's still going to get us to 2 over 2, which works out just to be 1. And 1 is our overall solution in this case. So remember, just look for the very biggest degree of any individual term at the beginning from the denominator, multiply numerator and denominator each by 1 over x to whatever that highest power is. A little distributing and a little simplifying, but then all you're looking for is if we have x in the denominator, those pieces go to 0. And if you still have an x up in the numerator, say you had a 2x, well, 2x is going to go to infinity, unless there was like a negative out in front. All right, I hope this helps out. Good luck as you're working through these.